So we'll look at one more example by hand here. And this is from the same exercise 7K task 1. So let's look at B and C. So a box contains 6 green, 3 red dice and 3 white dice. A die is selected at random from the box. The die's color is noted and it is not replaced. So not replaced. This experiment is repeated 4 times. Find the probability that a green die is selected fewer than 3 times. So the first question we would have to ask is, can we use a binomial model for this problem? And in this case, we can't, because we don't have replacement of the dice. So when we pick out one die, and it's not replaced, the probability is going to change every time you pick something out from the box. So we don't have a constant probability here. So we cannot use the binomial model. On C, on the other hand, we do not have, let's see, a die is selected at random from the same box, its color noted and the die replaced. So here we do have replacement. This experiment is repeated 4 times. Find the probability that a green die is selected fewer than 3 times. So with replacement, we can model this as a binomial experiment. So let's call this, okay, we have 6 green, we have 3 red, and then we have 3 white, right? So that's 12 dice altogether. And we're going to repeat this 4 times, so our n is 4. So find the probability that a green die is selected fewer than 3 times. Now, so we want to find the probability that a green die is selected fewer than 3 times, like this. Now, our probability here is, okay, on the first pick, the chance of getting a green die is 6 out of 12, because 12 is the total. So the probability is, again, 1/2. So we could just write 1/2 like this. And we could start by rephrasing this probability. So the probability of green less than 3 is the same as the probability of green being 0 plus the probability of green being 1 plus the probability of green being 2. These are the probabilities that we want to add together. And so green is a random variable that is binomially distributed with the parameters 4 and 1/2. So that's our starting point. So here we have not 1 but 3 probabilities we want to find. So we'll just start with the first one. Probability that picking out a green die is 0 is going to be, well, we have this C, right? We're doing this 4 times and we're looking for 0 green dice. It's going to be the probability to the power of 0 multiplied with 1 minus 1/2 to the power of 4 minus 0. And what happens to this C when you have 0 underneath? I could show you. It's going to be 4 factorial divided by 0 factorial multiplied with 4 minus 0 factorial, which is going to turn out to be just 1. We'll look at that in a minute. And anything to the power of 0 is 1, so 1/2 to the power of 0 is 1. multiplied with 1/2 to the power of 4. And we could abbreviate this to, okay, 4 factorial divided by 1 multiplied with 4 factorial. So 4 factorial divided by 4 factorial is going to be 1. So that's 1 times 1 times 1/2 to the power of 4. It's 1/16. So that's our first probability. Our second probability is the probability that green is equal to 1. That we get 1 green die. And that's going to be capital C for 1/2 to the power of 1 multiplied with 1/2 to the power of 4 minus 1. And we work this out the same way as before. This is equal to 4 factorial divided by 1 factorial, 4 minus 1 factorial multiplied with 1/2 multiplied with 1/2 to the power of 3, which is equal to, we'll need a little bit more space, so I'll just put it over here. 4 factorial, that's 4 times 3 times 2 times 1, and divided by 1 times 3 times 2 times 1, because that's 4 minus 1, that's 3 factorial. So we can strike these out and multiply that with 1/2 and 1/8, because that's 1/2 to the power of 3. So we have 4 divided by 16, which is the same as 1/4. Now, this turns out to be a cumbersome method, but it works, and I'm running out of space here. But we don't have to do this by hand, so I'm just showing you how it works. And in the next video, we'll do this quick and easy on the calculator.